Much is spoken about sending humans to Mars, the red planet that arouses the curiosity and imagination of many. NASA already has plans to take astronauts there in the coming decades. But is that the only possible destination in the solar system? What if, instead of Mars, we sent humans to Venus, the planet closest to Earth? It might seem like a crazy idea, as Venus is known to be a hell of heat, pressure, and toxic gases. The challenges of sending humans to Venus are undeniable, from scorching temperatures to crushing pressure. However, the possibility of colonizing the planet intrigued Dr. Paul Byrne, as he believes that despite the adverse conditions on the surface, Venus's clouds could offer a potentially habitable environment. Today, we will follow Byrne's arguments and understand why he thinks Venus is a more interesting destination than Mars for space exploration. What are the advantages and challenges of sending humans there? And also, what are the projects and missions that are already being planned to study the planet?
We have six images in total of the surface of Venus. But we know enough to sort of get a rough sense of what's going on. Now, the skies of Venus, which is the focus of this talk, they're an interesting place. We know that they're about 97% CO2, which interestingly is the exact same composition as the atmosphere of Mars. Mars and Venus have the exact same atmospheric composition. There's just a lot more air on Venus, and so it has weather. We know that there is a global layer of clouds. These clouds, unlike those of Earth, which are made of water vapor particles, they're made of sulfuric acid. Sulfuric acid is problematic for a whole pile of reasons, but it is also bright, and it reflects a lot of light. And so we all know Venus is the morning star or the evening star, depending on when you see it in the night sky, or the evening sky or the morning sky. And the reason it's so bright is because of that global layer of sulfuric acid clouds. Another name for Venus is Lucifer, probably an appropriate term for the planet.
You might be wondering why send humans to Venus. After all, if the planet is so hostile and dangerous, why consider this idea? First and foremost, Byrne asserts that sending humans to Venus would be a way to learn to live and work in deep space under challenging and varied conditions. This would be useful in preparing astronauts for future missions to other destinations, such as Mars, asteroids, or moons. Additionally, he argues that this would be a way to test new technologies and innovations, such as floating platforms, aircraft, spacesuits, communication systems, among others. Secondly, Byrne highlights that this exploration would enable cutting-edge science, exploring a little-known planet that could reveal many surprises.
So at first glance, Venus and Earth are quite similar. They are about the same size and about the same mass. And in fact, sometimes Venus is called our sister planet.
He cites some examples of scientific questions that could be investigated by such a mission, among them how Venus evolved from a potentially habitable planet to the infernal world it is today. What caused the extreme climate change that made the planet so hot and dry? And the most important question of all, if there is indeed life on Venus, especially in its clouds where conditions are more favorable. After all, signs of life seemingly exist there, in the form of the controversial signs of phosphine, a possible indicator of biological activity, which were detected in the upper layers of the atmosphere.
Maybe the case that microbial life has evolved in order to survive in the high clouds of Venus.
We can just pick one thing and go for it. And we can also work on the taboo topic of the search for life.
These are some of the questions he believes could be answered by a human mission. Now that you know why sending humans might be a good idea, you must be wondering how to do it. For these questions, he also has answers. Firstly, he explains that sending humans there does not mean landing on the planet's surface, but rather staying in the atmosphere at an altitude of about 50 kilometers.
But even then, there's something interesting about the sky of Venus. It is the only other place in the solar system that is the same temperature and pressure as this room. At about 55 kilometers altitude, slightly above the clouds of sulfuric acid, it's essentially room temperature and pressure. So an astronaut, conceivably, as long as she or he were shielded, wearing some sort of plastic suit to protect them from sulfuric acid droplets, and had a breather, a mask on, they could comfortably go out in shirt sleeves onto, say, the gondola of an airship and be perfectly safe. It's the only other place in the solar system at room temperature and pressure, and the Soviets took advantage of this.
Moreover, there is an abundance of sunlight that could be used to generate power. Secondly, he says that this would require the use of floating platforms that would be like giant airships, equipped with solar panels, scientific instruments, communication systems, and life support. These platforms would be inflated with helium or hydrogen, which would be lighter than air and could move through the atmosphere by controlling their altitude and speed.
In 1985, they flew 2 balloons, Vega 1 and Vega 2. Now, the Vega missions were wild. Turns out they were actually going to go to Halley's Comet. And some Soviet engineer pointed out, well, we need to fly past Venus to get to Halley's Comet. While we're going to Venus, let's just drop in a lander and a balloon. And they did. And the Vega 1 and 2 balloons flew for about 44 hours each. Now, they were small. As balloons go, they were about that wide. They had maybe 12-kilo payload. Very, very basic, simple stuff, but they demonstrated that you can fly a balloon on Venus. And in fact, it is one of the least inhospitable places in the solar system.
These suits would also need to be resistant to heat and moisture, and they would have to have cooling and communication systems. In addition to facing some risks, such as the possibility of leakage or rupture of the floating platforms, exposure to solar radiation, the difficulty of rescue or return in case of emergency, and also the uncertainty about the psychological and philosophical effects of such a long and isolated mission. In addition to these challenges, a mission of this kind would be very expensive and complex. However, he believes that it is possible and feasible with the advancement of technology and international cooperation.
And there was something else that was fascinating about a mission called Pioneer Venus, which NASA flew in the 1970s. In fact, Pioneer Venus flew from 78 to 1990. It orbited. And it had a set of probes that it deployed when it first got to Venus in 1978. And these probes detected something interesting in the atmosphere. What they found was that there's evidence for a sustained history of water loss. Now, I'm going to skip the details. It has to do with looking at 2 different isotopes of water. But the point is that these probes found evidence that Venus has lost at least an Earth ocean's worth of water over the past 4.5 billion years. Now, what that doesn't tell us is whether that water was in the form of steam in this hellish world that was always too hot, or if in fact, and this is the tantalizing possibility, Venus may once have had liquid water oceans. Now, these 2 scenarios are some of the 2 most important questions we have to try and answer in planetary science. And the reason they're important is because they speak to a fundamental question that I mentioned earlier. How do you get an Earth? And how do you keep an Earth?
Since the 1960s, several space missions have explored the neighboring planet, primarily conducted by the former Soviet Union and the United States. These missions have included orbiters, landers, balloons, and impact probes, collecting data on Venus's atmosphere, surface, geology, climate, and magnetosphere. Some of the most well-known missions involved probes such as Venera, Vega, Mariner, and Pioneer. Currently, a few space missions are still in operation, such as Japan's Aerospace Exploration Agency's Akatsuki, which has been orbiting the planet since 2015. These missions continue to study the planet using optical, infrared, ultraviolet, and radio instruments. Furthermore, new space missions are being planned or proposed by various agencies and companies, including NASA, the European Space Agency, the Japan Aerospace Exploration Agency, Roscosmos, the Indian Space Research Organization, and the private company Rocket Lab. These missions range from landers to aircraft that aim to investigate aspects such as geology, volcanoes, habitability, chemistry, and the potential existence of life on Venus.
But it's also of tremendous importance if we think about if we would find life on Venus. Did it have same origin as life on Earth, or did it really emerge in parallel? And this has huge implications also for us as humanity.
Finally, some projects and concepts for human missions also target the planet, but are still in the study or development phase, and may become a reality in the future.
And in the last 10 years, NASA's put a lot of work and time into developing technologies to allow us to fly balloons on the surface of Venus. And it turns out that because you don't have those high temperatures and high pressures, because it's room temperature and pressure, you can fly a balloon for weeks or even months at Venus. In fact, what we try and tell people is that balloons are to Venus as rovers are to Mars. We know that some of the rovers on Mars have lasted more than a decade because the conditions there are relatively benign. Well, so too could we do with a large balloon. We would fly this for months. It would be carried, just like balloons on Earth, by high altitude winds. And then at the bottom of this thing, you'd put a set of instruments in a gondola. And I'm going to finish with a short video that documents some of the test flight data we got last year. So take a look.
That's it, folks. I hope you enjoyed it, and don't forget to comment on what you thought of the topic below. If you're not already part of our community, hit the like button and subscribe. It's crucial for the channel to gain visibility, which in turn helps us create more content like this. Thanks a lot, and see you next week.